Okay, so what I'm going to do is give you a rundown on mechanics in Extension 2. The first thing we're going to look at is your simple harmonic motion. Okay, so for something to be in simple harmonic motion, the acceleration has to be in the form of minus n squared x. This can also be written as minus n squared x minus c. When c equals 0, then the centre is at minus n squared x minus 0, which is minus n squared x. So the basic form for your equations in displacement, velocity, and acceleration for simple harmonic motion is x equals a sine nt plus alpha and plus c. That's when it's shifted up, and that's the centre. The cos graph is also a good model for simple harmonic motion. You can also have it in the form, like there's a few other forms that it can take. Sometimes it's a combination of a sine curve and a cos curve. And when it's like that, it's really handy to know how to put it into the auxiliary angle method so that you can find its amplitude. So all of these graphs, basically what they do is they model something that oscillates between 2 points. So it goes from A down to minus A. And if you had your shift, it would go up C, and it would go from, your oscillation would then be like about C, and it'd be above C, below C, above C, below C. Both the cos and the sine graph are really good models for simple harmonic motion. Okay, so the next thing I just want to look at is I just want you to be able to prove that something is in simple harmonic motion. And I want to look at also what the amplitude and the period of a motion is. Okay, so if you want to prove that is simple harmonic motion, what you have to do is you have to find the acceleration, and you have to show that it is in the form of minus n squared x minus c. So if you differentiate it once, because it is with respect to t, that would be 4. Now sine will go to cos 3t times 3. So that will be 12 cos 3t. If you differentiate again, that would be minus 3 times 12 sine 3t, which is minus 36 sine 3t. Okay, now this here, to get it into the form of minus n squared x minus c, if you take out the minus 4, that would be, take out, not the minus 4, take out minus 9, and that would be 4 sine 3t, and you can see that this just matches this at the top here. So that's going to be minus 9x, because 4 sine 3t equals x. So that means acceleration is in the form of minus n squared x. N is equal to 3, because that's n squared is 9. The centre would be x equals 0. The period of the motion is 2 pi on n, so it's 2 pi on 3. You can't get the amplitude from this, but if you come back up here, the amplitude is equal to 4. So once something's in simple harmonic motion, then you're able to quote any of the velocity formulas, which I'll run through in a minute. You just want to look at another one. Let's just look at 5 sine 4t plus 3 cos 4t plus 5. I just want to show that this is in simple harmonic motion. So if you differentiate once, the 5 sine 4t will go to 5 times 4 cos 4t, and the 3 cos 4t will go to minus 3 times 4 sine 4t, and the 5 will go to 0. So that means that will be 20 cos 4t minus 12 sine 4t. So if you differentiate again, 20 cos 4t will go to sine 4t with a negative times the 4, because times the derivative of the inside. And this is 12 cos 4t times the 4. So you get minus 80 sine 4t minus 4 12s, which is 4 12s are 48 cos 4t. So now what we have to do is we have to rearrange this top one to try and get it in terms of x. So we're after this part here, which is 5 sine 4t. 5 sine 4t plus 3 cos 4t, that equals x minus 5. So if you look here, there is a common factor there of 16. So if we take out the minus 16, we get 5 sine 4t plus 3 cos 4t, which is what we would like. And then in place of this, we are just going to put x minus 5. And this is, therefore, it is in the form of minus n squared x minus c. So your centre here is 5. So your centre is x equals 5. N is equal to the square root of 16, which is 4. So the period would be 2 pi on 4, or pi on 2. Now, to get the amplitude when something is in this form, we need to look at these front ones here, and we can put it into the auxiliary angle method. So sine would keep the same sign. So your r would be the square root of 5 squared plus 3 squared, which is the square root of 25 plus 9, which is root 34. And that would be your amplitude. Just one other one, just to show that this is simple harmonic motion. If you happen to get something like this, and we want to show it is in simple harmonic motion, it will be in simple harmonic motion. This actual graph will look like this. Okay, because it's like your normal sine graph, but then because we're squaring it, it'll go boom, 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 and it'll just be on the positive half of the axis. Okay, so if I differentiate this twice, once, now it's a little bit harder to do when it's in this form. So what we need to do is you need to get the sine squared 4t, and if you think of your integration rules where that equals cos 8t, that's your 2 theta rules. It's actually even on the formula sheet, and then you use that instead to differentiate. It's a lot easier to differentiate because you don't have to worry about a function to a power because of that 2 up there. So x dot is a half, 1 will go to 0, cos will go to minus sine 8t times 8. So that's going to be a half times 8 sine 8t, which is going to be 4 sine 8t. If you go again, x double dot is 4 times minus cos 8t times 8. So x double dot is minus 32 cos 8t. So now we have to somehow replace it with x. So once again, we're better off going to this one. We want to find cos 8t. So that would be 2x equals 1 minus cos 8t. If I swap those, you get cos 8t equals 1 minus 2x. So x double dot is minus 32, 1 minus 2x. Oops, sign error. Just noticed a sign error. Okay, so the sign error was that one there, because when you differentiated the sign, you got plus cos. So that means that's a plus. Okay, so that's 32, 1 minus 2x, and if you take out a common factor of minus 1, 32, 2x minus 1. So the centre is actually at 2x minus 1 equals 0. The centre is actually at a half. You could take out the 2 there and go, probably better doing that. X double dot, let's just take the 2 out. That'll be minus 64, x minus a half. So looking at that, the centre is x equals a half. The radius, the n is equal to root 64, which is 2. So it's 2 pi on 2, which is 8, 2 pi on 8, which is pi on 4. Yeah, and looking at the amplitude of this one, if you're better off looking in this form here, because that's your basic cos graph, would be a half. Now, with simple harmonic motion, if you look at like your basic graph like there's your amplitude minus A. This is 2 pi, so your period's 2 pi. Your period is 2 pi on M. Your amplitude is the A, which is like how far above and below the central position it is. So things that you're going to be looking at here is you've got your velocity equations, which is v squared is n squared a squared minus x squared, and v squared equals n squared a squared minus x minus c squared. These can actually be derived from the acceleration formula, which I'll do in a minute. And then you have your acceleration, which is x double dot is minus n squared x minus c. That's when the centre is C. If the centre is 0, then it's minus n squared x, because C equals 0. So this one, the centre equals 0, and this one, the centre equals C. These are not on your formula sheet, and it is a good idea to learn them, because you don't want to always have to be deriving them. But if there's room for deriving them, it'll be in the question. So the other thing that is really important to this is being able to find your max speed or velocity and your max acceleration. So because you've got v squared is n squared, a squared minus x squared, your maximum speed is at the centre. That's where it's going the fastest. And if you draw up this little thing here, this is your centre. You have your endpoints. This is x equals minus a, x equals a, and this is x equals 0. You can also shift it when it's c. Okay, so v equals 0 is your endpoints. That's here and here. They're v equals 0. And in the centre, that's where v is a maximum. The acceleration at your endpoints, the acceleration at the endpoints is a maximum. And the acceleration is equal to 0 just here at the centre, because that's where it's going the fastest, and the fastest is talking about v. The derivative of v is acceleration, so when the derivative of velocity equals 0, it is going its fastest. So at the centre, if x equals 0, v squared equals n squared a squared minus 0 squared. So v is plus or minus na. And it can be plus or minus depending on the direction. If it was speed, for the speed, it is just na. Now, the other thing, that's where the max speed is, so, or the max velocity, that's na. It would work the same if your centre was at x equals c, because you just put in x equals c, you just put c for the x, and that will give you the 0, and the v squared is n squared a squared, so v is plus or minus na. If you want your maximum acceleration, so your acceleration is minus n squared x, that is at your endpoints, so it's going to be minus n squared times, and it could be at plus or minus a, so it's just plus or minus n squared. A is your maximum acceleration. And it's the same even if the centre was at C, it will still be the same maximum acceleration. Okay, so just running through a question here. So a particle moves in simple harmonic motion, there it is there. Find its centre, period, amplitude and extremities of the motion. So you could do this by sketching it. We can see, first of all, for the period is 2 pi on n, and n is always the number in front of the t. So that's a 2. So it's 2 pi on 2, which is pi. That's the value you divide x by. Like all the x's will be halved. The centre is your plus 2. So the centre is x equal 2. And it goes wherever, like where the 2 is, so there's the 2, this 4 is your amplitude. So the amplitude is equal to 4. So it'll go up 4 to 6, and it'll go down 4 to minus 2. So it's a cos curve, so it'll go between these 2 points. So if you wanted the endpoints or the extremes of the motion, that would be at x equals minus 2 to x equals 6. The initial phase and where is the particle at t equals 0. The initial phase, that's when t equals 0. The initial phase is pi on 3. The phase is just like this plus alpha, or it's just your shift. That's what they call the phase. So when time equals 0, where is it? It is 2 plus 4 cos pi on 3. And pi on 3 is equal to cos 60, so that's a half. So it's 2 plus half of 4 is 2. So it's 4 metres to the right of the origin. That's its position. Okay, find the first time when the particle is at the centre. So find the first time when the particle is at the centre of the motion. So the centre of the motion, that's here. That's going to be, for this one here, the centre will be at x equals 2, because it oscillates about 2. And the extremities, remember, it was 6 to minus 2. So it's like having, like the centre is 2, and then it oscillates, it goes up 4, so it goes to 6 and down. So it goes between there and there. So, okay, so the centre is when x equals 2. So it's 2 plus 4 cos 2t plus pi on 3. So that means 0 equals 4 cos 2t plus pi on 3. We could probably get this just as easy just by graphing it. Sometimes graphing it is just as easy. So you get 0. So 2t plus pi on 3 equals. So cos is equal to 0 at 90. That's the first time. And then it will be, and that will give us a positive thing. Like we could go 90, then we could go 3 pi on 2. But we won't be needing that one. So it's 90 minus 60, which is 30. So it's pi on 6. And then it's pi on 6 divided by 2. That gives you pi on 12. So that's the centre. When is it first at the origin? So you just put 0 in, 2 plus 4 cos, 2t plus pi on 3. So that means you get minus a half equals cos 2t plus pi on 3. So cos is negative here and here. So we want when is it first there. Cos is equal to a half at 60. So that's pi minus pi on 3. So 2t plus pi on 3 equals. So 2t equals pi minus pi on 3 minus pi on 3. So 2t equals pi on 3. Because that's 180 minus 60, which is 60. So t is pi on 3 divided by 2. So that's going to be pi on 6 seconds. That's when it's first at the origin. What is its maximum displacement? So the maximum displacement is the furthest it is from the origin. So the maximum displacement is actually 6 metres, and the minimum displacement is the furthest away from the origin. So that's going to be at minus 2, because it goes between 6 and minus 2. Okay, so now when we're looking at this here, what we're going to do is going to prove its simple harmonic motion. The first part 2 says to express that into that form. So this is R. A is the number in front of the sine, which is 1, and B is the number in front of the cos, which is root 3. That's alpha. Tan alpha is root 3 on 1. Therefore, shift of tan alpha, that would give you pi on 3, or 60 degrees. R is equal to the square root of 1 squared plus root 3 squared, which is the square root of 4, which is 2. Okay, so in that form, it would be 2 sine, you choose whatever the first one is, sine 4t plus pi on 3. That's B. And C. Okay, prove its simple harmonic motion. I could probably just use this one here, or I could differentiate the one that's above twice. So you differentiate it once, and you get 1 will go to 0. I mean, because I got that in that form there, I could probably just do that one. So you go 2, sine goes to cos. I'm just going to do this one, plus 4 pi on 3 times 4. And then x double dot would be 2, that will be minus sine 4t plus pi on 3 times 4 times 4. So x double dot actually equals the minus 16 times 2 sine 4t plus pi on 4. Can you see how I've just kept the 4's out? Because that's my n squared. So it's minus 16 times. So what is 2 sine 4t on pi on, it's not pi, it's 4t pi on 3, because I'm keeping that there. So that is actually equal to x. So that's going to be x. So it's all the form of minus n squared x, so therefore it is simple harmonic motion. Okay, and the amplitude is your r, which is the square root of 1 squared plus root 3 squared, which is root 4 or 2. And when does the particle first reach its maximum speed? Okay, so the maximum speed is at the centre of the motion. So when does it first reach the centre of the motion? So the centre of the motion in this one is x equals 1. So if you've got x equals 1 plus sine 4t plus root 3 cos 4t. Now you could also have used the other one, which is 2, just go back and see what it was, 2 cos, where is it? Back. Okay, when we put it into that form, what was it? It was 2 sine, and it was 4t plus and pi on 3. So you could also use that as well. So the max speed will be at the centre of the motion, and we want the time when it reaches its max speed. Okay, so the time when it first reaches its max speed, like if you did it off this one, that would be when x equals 0, because that's where the centre is. So it's when sine 4t plus pi on 3 equals 0. So that means that 4t plus pi on 3 equals 0, and we're going to also have to go with pi, because if we just do the 0 one, it's going to give you a negative time. So looking at that then, you could also do it off the other one. So you go 4t equals pi, I'm going to take this one, pi minus pi on 3. 4t equals 2 pi on 3. T equals 2 pi on 12, which is pi on 6. If you did use the other one, that would be when x equals 1. So you go 1 equals, and you'd have sine 4t plus root 3 cos 4t. And then there's 0. So sine 4t plus root 3 cos 4t equals 0, because the 1's go out. This is going to create a tan. So when you create a tan out of this, that means that that's going to be sine 4t. So sine 4t equals minus root 3 cos 4t. Let's get a little bit neater. So sine 4t equals minus root 3 cos 4t. So then when you divide both sides by cos 4t, you create a tan. So you get tan 4t equals minus root 3. Tan is negative there, so that's why it's pi minus 60. So pi on 3, so it's 2 pi on 3, but it's 4t this time. So t is 2 pi on 3 divided by 4, which is just pi on 6, which gives you the same solution.